Welcome to session 2 with focus on capital allocation line, which is an important concept in understanding how to allocate capital to risky assets. The learning goals for session 2.2 are: you should be able to allocate capital across risky and risk-free portfolios. You know how assets are considered to be risk-free assets and why. Students should also be able to compute the capital allocation line with and without leverage. Risk-free assets. Risk-free assets are issued by the government and are default-free bonds. Even the default-free guarantee by itself is not sufficient to make the bonds risk-free in real terms. The only risk-free asset in real terms would be a perfectly price-indexed bond. Nevertheless, it is common practice to view treasury bills as the risk-free asset. Their short-term nature makes their prices insensitive to interest rate fluctuations. Moreover, inflation uncertainty over the course of a few weeks or even months is negligible compared with the uncertainty of stock and market returns. Money market funds, including treasury bills, other treasury and US agency securities, and repurchase agreements are also considered risk-free assets. Asset allocation across risky and risk-free portfolios. History shows us that long-term bonds have been riskier investments than treasury bills, and that stocks have been riskier still. On the other hand, the riskier investments have offered higher average returns. Some of the portfolio may be in risk-free treasury bills, some in high-risk stocks. The most straightforward way to control the risk of the portfolio is through the fraction of the portfolio invested in treasury bills or other safe money market securities versus what is invested in risky assets. The question is, how much of the portfolio should be placed in the risk-free money market securities, called Portfolio F, versus other risky assets classes, called Portfolio P. Basic asset allocation. Let's start with an example. Assume the total market value of an initial portfolio is 300,000, of which 90,000 is invested in the ready asset money market fund, which is a risk-free asset for practical purposes. The remaining 210,000 is invested in risky securities, 113,400 in equities, and 96,600 in long-term bonds. First, we calculate the proportion of stocks by simply taking the equity value divided by the total risks of assets. So this is a proportion of 54%. We also calculate the weight of the bond, which is simply the amount of bonds divided by total risk assets, which is about 0.46, or given the fact that it all adds up to 100%, we can simply subtract 1 minus the weight of equity. As a next step, we calculate the weight of the risky portfolio P, denoted Y. By computing Y, total risky assets divided by total market value, we receive 0.7 or 70%. As all weights must add up to 1, we know that the difference of 0.3 or 30% is invested in the risk-free asset. If we want to know the weights of equity and bonds based on total market value, we repeat the previous calculation with the corresponding stakes of equity and bonds. Rather than thinking of our risky holdings as equity and bonds separately, it is better to view our holding as if they were in a single fund that holds equity and bonds in fixed proportions. In this sense, we may treat the risky funds as a single risky asset. As long as we do not alter the weights of each security within the risky portfolio, the probability distribution of the rate of return on the risky portfolio remains unchanged by the asset reallocation. One risky asset and a risk-free asset example. Now let's examine the risk-return combination available to investors once the properties of the risky portfolio have been determined. This is the technical part of capital allocations. With a proportion y in the risky portfolio and 1 minus y in the risk-free asset, the rate of return on the complete portfolio is denoted RC. So we can actually calculate the expected return of the complete portfolio by simply adding y times expected return of the risk portfolio plus 1 minus y times the risk-free return. This can be rewritten and simplified, so it gives you RF plus y times the risk premium. In our example, this can be rewritten 7% plus y times the risk premium of 8%. With a proportion y in a risky asset, the standard deviation of the complete portfolio is the standard deviation of the risky asset multiplied by the weight y of the risky asset. The standard deviation of the risk-free asset is 0, therefore it does not add to the risk of the complete portfolio. The investment opportunity set. The next step is to plot the portfolio characteristics with various choices for y. If we invest 100% in the risk-free asset, our expected return will be 7% with a standard deviation of 0, as shown in portfolio F. If we would invest 100% in the risky portfolio, our expected returns would be 15% with a standard deviation of 22%. Connecting F and P displays the line with all possible expected returns and its given standard deviations for different y's, ranging between 0 and 1. This line is called the capital allocation line. It shows all risk-return combination available to investors. In this graph, you also see that the slope of the capital allocation line is defined by the risk premium divided by the standard deviation of the risky portfolio. As a result, the linear function of the capital allocation line is defined by the intercept, RF, and the slope times the standard deviation of the complete portfolio. To determine the function of the capital allocation line based on the complete portfolio return on the y-axis and the complete portfolio standard deviation on the x-axis, we need to know its intercept and the slope of the capital allocation line. Comparing the capital allocation line equation, which is defined by the risk-free rate plus y times the risk premium, we realize that the weight of the risky portfolio is equal to the standard deviation of the complete portfolio divided by the standard deviation of the risky portfolio, and therefore can be replaced by this term. The slope or reward to volatility ratio is usually called the Sharpe ratio, as shown in previous sessions. To invest in the risky portfolio more than 100%, you could borrow additional funding at the risk-free rate. The risk of a borrower's default leads lenders to demand higher interest rates on loans. Therefore, the non-government investor's borrowing cost will exceed the lending rate of 7%. Suppose the risk-free rate for borrowing is 9%. Therefore, the lending range slope is equal to 0.36 and calculated simply by the risk premium 15 minus 7 divided by 22. The same can be applied for the borrowing range slope, which equals 0.727, or calculated by 15 minus 9 divided by 22. As previously calculated, if you need to borrow funds at a higher risk-free rate, your slope becomes flatter, as shown in the graph below. After P, where you invest more than 100% in the risky portfolio. This method is used to leverage returns, but it is risky. If the expected return of the risky portfolio falls below the risk-free rate, you would lose more than 100% of your initial wealth. In practice, borrowing to invest in the risky portfolio is straightforward if you have margin account with a broker. We are at the end of session 2.2. After having carefully studied the slides and relevant chapters in the book, please start with the review questions.